I wanted to make a recording of number 45 because I messed it up in class and I just didn't want to post a video that had a mistake in it. The problem was 1 minus 3/4 v plus 2 is negative 5. And one of the things that happens is we can make mistakes distributing, and that's what I did in class. If you look, we need to clean up the left-hand side before we start solving. So let's start cleaning it up. I can tell that I'm going to have to distribute this negative 3/4 times both of those things. I could distribute 3/4, but then I'd have to subtract both terms. So I'm going to distribute a minus 3/4, and that way I won't have to do as 2 steps here. A negative 3/4 times a v would be a negative 3/4 v. Now negative 3/4 times 2, I'm going to come off to the side because I messed that up. This is where I made my mistake in class. Negative 3/4 times 2, I'm going to make that a 2 over 1, okay? Let's reduce it first. I messed up totally on this in class, so I want to go ahead and do this one on a video to make sure that people get a chance to see it correctly done. 2 goes into 2 one time, 2 goes into 4 2 times. That becomes negative 3 times 1 on top is negative 3, and 2 times 1 is 2, so it's minus 3/2 equal negative 5. Okay, so that green part's where I messed up in class. We did redo it in class, but I still wanted to make a clean video of it. All right, now I can still do some cleaning up here. I have 1 minus 3/2. You know, sometimes you might want to have some workspace off to the side. That's the same thing as 2 over 2 minus 3 over 2. That would be a negative 1/2. So I would have negative 1/2 minus 3/4 v equal negative 5. Now, when I have a big mess like this, I can just do the fractions. It's not wrong to do the fractions, but a lot of times you can make your life a lot easier if you get rid of them. And when you get rid of them, that's called clearing the fraction. And you look and you pick, basically the least common multiple is what you called it back in 6th and 7th grade, the least common multiple of the denominators 2 and 4. What's the smallest number that both of those divide into? It would be 4. So what I'm going to do is I'm going to multiply every single term here by 4. I'm just going to write it next to each term so I can see it a little bit better because I've been having trouble today staying on track. 4 times negative 1/2. 2 goes into 2 one time, 2 goes into 4 2 times. That becomes a negative 2. 4 times negative 3/4. 4s cancel out and become 1s. So that would be negative 3v. Yay, the fractions went away. And 4 times negative 5 is negative 20. That's the hard part, is cleaning it up, okay? And it's very meticulous work, and you make a little mistake and you're going to get way off. We're going to solve for v now. Now that I'm solving, I can switch from doing PEMDAS and all kinds of things to clean it up to doing PEMDAS backwards. PEMDAS backwards says we would add or subtract first. So I've got a minus 2 here. I can add 2 to each side to get rid of it, okay? That's 0 minus 3v. Well, 0 minus 3v is a negative 3v. Negative 20 plus 2 is negative 18. Getting v by itself, I'll divide both sides by negative 3 because those are joined together with multiplication. 1v is equal to 6. And there's our answer. Okay, I'm going to do 51 next. If you look at 51, let's clean. We got lots of stuff to clean up. Everything is on the left-hand side. It's kind of funny. In Algebra 2, you're going to learn that you kind of want to do that a lot of the times. But right now, it's not helping us, is it? Let me, if I notice, I've got this, it doesn't almost look like there's any multiplication to do or anything, but if I realize there's a 1 there, there is some multiplication to do. Remember, I'm simplifying here. And so I'm thinking about PEMDAS when I do this. And inside the parentheses, there's nothing to clear up. So there's not really that to do. There's no exponents here. So I'm looking to multiply or divide. That's why I was kind of made that statement about multiplication. I'm going to copy down things that aren't changing. I'm going to put x minus 13. That really didn't need a parentheses. But now I've got a negative 1 in front of the x minus 5. Negative 1 times x is a negative 1x. I'm going to go ahead and write the 1 with it just this time just to emphasize it. And a negative 1 times a negative 5, remember I can think of this as plus negative 5, so I can look at it as a negative 5, Negative 1 times negative 5 is a positive 5. And then I got a plus 2x equals 0. Now, I have this x here. I'm going to go ahead and put a 1 in front of it. Do you notice that I have 1x minus 1x? Those would add up to 0, so they cancel each other out, or they add up to 0. And then I've got these 2 x's here. I can just write them down. They're all the x's that are left. I'm combining like terms now, and I noticed I had all these x's, so I started with those. Now I'm going to clean up the numbers. Negative 13 plus 5 is negative 8. So 2x minus 8 is equal to 0. Now let's solve for x. Now I'm switching gears, aren't I? I've simplified all I can. This is what that mess really is. It's 2x minus 8. So let's get x by itself. Now I'm going backwards on PEMDAS because I'm solving. That's what the rule is. So I can add, I've got minus 8 here. The opposite of a minus 8 is a plus 8. I'm trying to do any adding I can do first to simplify. 2x minus 0 is just 2x. And 0 plus 8 is 8. X isn't by itself, but I can divide both sides by 2. X equal 4. Watch, if you're watching this video, you may want to watch to see if there's another one posted over the other ones. I figure this will probably fill up this video. I'll probably make a separate one for 55, 57, 59. Okay. If I want to clean this up, and I know that's what I need to do, because look at how much stuff's on the left-hand side. I notice I've got, I can't simplify anything in parentheses. There's not any exponents, so I need to look. I have, there's some parentheses I don't really need here. The ones that I don't really need are the ones on this b, and then this b minus 3 at the end, plus b minus 3. Now, I do need the parentheses because there's a negative out front of the 1 minus 2b. Now, if you remember, we could think this way. There's a bunch of different ways we could think here, but here's one way that seems to work well for a lot of people. There is a minus 1 of these things. I could put in the 1 the lazy math guy didn't write in, and I could distribute negative 1 times each of these. And I'm going to come back and make a statement about that in a minute. But right now, negative 1 times 1 is negative 1. And negative 1 times a negative 2b, take that as the sign of the 2b, because you can look at it as a plus minus 2b. That would be a positive 2b. I want you to notice something. When I did that, you see how I had this subtraction sign out front? That 1 became a minus 1, didn't it? Became a minus 1. That minus 2b became a plus 2b. They both switched signs. When you have a minus or a negative in front of parentheses, what you could do is just switch the signs on both of the terms inside. You could multiply by negative 1, or you can just switch the signs. And some people kind of get used to doing that just so they can work faster. So that's what a negative does, is it changes the signs on everything. Okay, once we get it out of there, however you chose to do it, we've got some like terms to combine. I'll use yellow to circle all the b's. Look at all these b's. There's a b. That's a 1b, right? There's a plus 2b. We're up to 3 b's now. Oh, there's another b. 3 b's and another b make 4 b's. Let me write those b's down. Now I got some numbers I can combine. I'll circle them in blue. There's a minus 1, or a negative 1, minus 3. You could think of that as negative 1 plus negative 3, or negative 1 minus 3, but either way it's going to be minus 4. And all of that equals to negative 4. Okay? So now I'm going to start solving for b, because I've got the left side simplified. We add or subtract first, so I'll add 4 to both sides. I knew to do that because PEMDAS backwards says we do that. Negative 4 plus 4 is 0. Oh, wow. If I want to get b by itself, the opposite of multiplying by 4 is dividing by 4, and 0 divided by 4 is just 0. That wasn't too bad. I thought I'd put 59 on here since I seemed to be able to fit it. If you remember in the last video, we had something, the thing that's weird looking about this one is just these absolute values of n's. Just look at them as something that you're just counting how many of them you have, okay? I have 3 of these absolute values of n's, but if I want to simplify this left-hand side, there's a negative in front of a parentheses. In the last problem I worked on the video, we said we could fill in a 1 and say that we can multiply negative 1, we could kind of fill in that 1 here if we wanted to, and say negative 1 times 2 absolute value of n would be negative 2 times the absolute value of n. You're just treating that absolute value of n as any old variable. And then if I'm distributing negative 1 times negative 2 would be a positive 2. Note again what happened here. When I had that negative in front of this parentheses, the positive 2 absolute value of n becomes a negative 2 absolute value of n, and the minus 2 becomes a plus 2. All that negative out front was switch the signs on both terms. Okay, so just trying to get that worked out. The more you hear it, the easier it's going to be to deal with it. Now, these absolute value of n's look weird, but let's just call them things. I have 3 of those things minus 2 of those things. That means I have 1 of those things left over, and I could write it as 1 times the absolute value of n. I'm just going to write absolute value of n, okay? So that was combining those into this term. Now there's a plus 2 that I'll just add on because I can't do anything with it. Okay. I'm going to get that absolute value by itself. If I want it by itself, I could circle it. Sorry for that line on the bottom. My pinky hit it. The opposite of adding 2 would be subtracting 2. I would have the absolute value of n is equal to 7. Okay, so we know one answer would be 7. The absolute value of 7 is 7. But there's another answer that would work. Anytime we see these absolute values, we have to stop for a minute and say, what could I put inside of there that would give me 7? 7 would work, but wouldn't negative 7, the absolute value of negative 7 would also be 7? Because the absolute value just gets rid of makes everything positive. It represents a distance, and we never talk about distance in a negative way. So I've got 2 answers, 7 and negative 7.